Integration by substitution, or otherwise known as change of variable. Okay, so we're integrating this trig function. Looks fairly complicated, and the substitution is u is equal to sine x plus 1. And just to clarify, the plus 1 has got nothing to do with the angle, so you can think of it as 1 plus sine x as well. Okay, so sine x is just u minus 1. 1 plus sine x is u, so that's going to be u cubed, and then for the dx we always differentiate the substitution, and now we're swapping these two around, so I'm going to put the dx on this side, put the cos x on this side, so dx is this will be du over cos x. And this may seem a bit unusual because we're replacing dx with this, and there's still x in there. So watch what happens then. So we're integrating. I've done nothing with this cos x. There's nothing in here that suggests I can replace the cosine of x there with a u term. So I still have this. The sine x I've replaced with u minus 1. The 1 plus sine x to the power of 3 I've replaced with u cubed, and the dx I've replaced with du over cos x here. Okay, and something interesting happens here. You've got cos x, you've got cos x in the denominator, so these cancel, leaving you with everything in terms of u. Okay, expand the brackets, and now we have simple terms to integrate. If we undo the substitution right now, we end up with these terms, but we're not going to. We're going to simplify, factorize and so on first, and then undo the substitution. So multiplying the denominators together and then cross multiply, we get a single fraction. Factorizing, and then we undo the substitution, so replace the u's there with sine x plus 1 in brackets, like so. Add on the constant of integration. Example 3. So yes, we can use trig for substitutions. So I'm changing variable from x to theta. So if I focus on the dx first, so I need to differentiate my substitution, and then rearrange to make dx the subject. So I can replace that dx with cos theta d theta, which I've done here. Now I've got 1 minus x squared, so if you square both sides, x squared is sine squared theta, like so. And we know 1 minus sine squared is equal to cos squared theta, but we're square rooting, so we square root cos squared and we get cos in the denominator, like this. And then these cancel, and we get something really simplified. So we have theta, but that's not the final answer. We have to undo the substitution. So using x equals sine theta, so we need to rewrite this in terms of just theta is equal to. So if we do sine inverse on each side, so I'm actually doing this, so sine inverse of x is equal to, and I do sine inverse on the right hand side as well of sine theta. A function and its inverse will cancel, like so. So our theta is just equal to sine inverse of x, or we can also use the arc sine x notation as well. So our final answer would be equal to either sine inverse of x plus a constant of integration, or we can say arc sine x plus a constant of integration.